There we go. All right, so we're given these two equations. We've got our system of equations here. And what do we see that we can do? How do we go about this? Say it again. I know that x equals this thing, so I'm going to substitute that into this equation in place of that x. So we're going to make this be 6 times, instead of x, we're going to put in what x equals, that 3y plus 23. And then we're going to finish out that first equation, our minus 3y equals 18. Oops, sorry. There we go. We're going to fix that y to make it look actually like a y. There we go. Now what are we going to do? Distribute. 6 times 3y is going to give me 18y. 6 times 23, we're going to use our calculators because that's not one I know off the top of my head either. That's 138 minus 3y equals 18. Now what? We can combine some like terms. I've got 18y and minus 3y. That's going to give me 15y plus 138 equals 18. Yep. Subtract that 138 from both sides. And we're going to have that our 15y equals negative 120. Gorgeous. Perfection. Divide by 15. And we get that y equals fantastico. Whew, we're done, right? My whole answer. What do we need to do? Find our x, substitute it back in. I'm going to take my x equals equation because that makes my life way easier. We're going to have our 3 times y, but now I know my y is going to be negative 8 plus 23. So 3 times negative 8 is going to give us negative 24 plus 23. So what does our x equal? Negative 1. So our final answer, our solution, is the point negative 1, negative 8. Okay, questions on this one? Because substitution works super duper awesome when we have an x equals or a y equals, or when I can make one of my equations be x equals or y equals kind of easily and with not too many fractions. But what if instead of an x equals, I had my 3x or 6x minus 3y equals 18 and something like 4x plus 5x equals 7. Ew, neither one of those would work well as an x equals or a y equals. So we're going to have another technique that we talk about today that works really well for when we don't have an x equals or a y equals, or the one we can get to. So what that's called is called elimination or linear combination. It uses both names. I tend to say elimination just because linear combination has way more syllables. But
so loud.
I mean, it does.
Yeah.
They mean the same thing. Elimination is just like what we colloquially call it linear combination is the technical term, but it's like using summation instead of sum. It's a lot. It's doing too much. And we are not about that doing too much life right now. So when we are going to be solving algebraically using elimination, we are going to be using addition, mostly. You can use subtraction, but I don't recommend it. I'm going to almost exclusively use addition. There's nothing wrong with using subtraction. It just winds up with a whole lot of sign games that are really easy to mess up. So using subtraction is a risky strategy. It's not wrong. It's just risky sign-wise. So I tend to use addition because we're better at signs with addition. So, but it's not wrong. You can use subtraction. But there will be some equations where you wind up then with 6 negative signs, and then you're trying to subtract things. It's just a mess. So I'm going to go with addition unless you're super duper confident. We're using addition or subtraction to eliminate, that's why it's called elimination, one variable which means our equations need to have the same number on one of our variables, which we may need to multiply or kind of manipulate that way, but we'll talk about that when we get there. So we're going to start with a fairly simple one. It's going to look very much like the sum of two numbers, difference of two numbers question we ended with yesterday. Like this. So we're going to start with this one. I have x plus y equals 7 and x minus y equals 5. What we're looking for with elimination is I need to have one variable that has the same number and opposite signs. That's what I want, because that lets us use addition. So if we look at this system here, what number is with my x right here? What number's in front of it? 1. So there's an invisible 1 in front of it. How about with the y? 1. How about on this one? Same. We've got a 1 and a negative 1. So what we're looking for is a variable that has the same number. So I've got 1s on everything, and it has opposite signs. So what we're going to do is we're going to start by eliminating out our y's. I've got the same number. They both have 1s. One's positive, one's negative. What we're going to do with these is we are going to go old school elementary style addition, where I take columns of things to add together. Oop. So I'm going to put a plus right here and a line like this. So old school style addition. So we're going to add in columns. So I'm going to take 7 plus 5. What do we get when we do 7 plus 5? 12. Then we're going to do 1y plus negative 1y. What do we get? If I have a positive 1 and a negative 1? 0. 0 y's. And then how about for my x's? I have 1x plus 1x. 2 x's. So I'm taking my two equations and smashing them together. All those signs kind of drop down too. We have a plus here, and our equals stays right here. So I have 0 y's. That means I don't really need to write that there. So what this tells me is that I have that 2x equals 12. Can we finish solving this? Divide by 2. So our x equals 6. But we still need to go back and catch our y because we do need to make sure we get our ordered pair that has our solution. So I can grab either one of the equations. It genuinely does not matter. I'm going to grab the top one, where I know that my x is 6 plus y equals 7. That's what I used down here. So what does y equal? 1. So my solution is the point 6, 1. So if we add things together in columns, we can eliminate out a variable. Questions on this first one? Okay. Here's our next one. And this is one that I'm like, we technically could use subtraction on it, but it makes things super gross. Because we'd be subtracting negatives. There's literally 6 negative signs here, and I don't want to have to do that. So we have our minus 2x minus 9y equals negative 25, and minus 4x minus 9y equals negative 23. That's fine. Like, we can do this. If we look at this, this is where we can see this one would really be quite awful to try and do a substitution. If I tried to solve this to get an x equals or a y equals, it would be gross. Doable, but gross. So what we're going to do is we're going to try and add these together in columns, but right now I don't have the same number with opposite signs. I don't have anything where I can eliminate it out. But what I do have is a couple of equations that have way too many dang negatives. So what we're going to do is we're going to take one of these and we're going to make it have very much less negatives. What's up? Exactly right. I'm going to take one of my equations and I'm going to multiply it by -1. I'm going to pick the top one arbitrarily. It genuinely doesn't matter which one we manipulate. We can manipulate both if we want to. But I'm going to take this top equation, this whole kit and caboodle, and we are going to times it by -1. And I'm going to put it over here. So negative 2x times -1 is positive 2x. Negative 9y times -1 is plus 9y. And negative 25 times -1 is positive 25. Now I'm just going to bring my second equation over, this guy over. Minus 4x minus 9y equals -23. Because now what we have is I have a variable, y, that has the same number on it with opposite signs. One's positive, one's negative. So I can take these and add them together. And that's exactly what we're going to do. I'm going to come through and I'm going to add these two equations together in columns. So I'm going to have my 25 plus -23. What is 25 plus -23? 2. We've got our, wrong color, 9y plus -9y. What is 9y plus -9y? 0 y's. And we have 2x plus -4x. What is 2x plus -4x? I was like, Thanks, Derek. Yeah, let me press. Thank you. What is 2x plus negative 4x, guys? Negative 2x. Okay, since we have 0 y's, we don't really need to write that down. So I'm going to drop that off on my next line. Oh, I don't like this pen. Oh, sorry, throwing things at you. Over there. All right, so we've got our minus 2x equals 2, because I don't need to have the 0y there. And then we're going to divide both sides by negative 2. We're going to get that our x equals negative 1. Now we're going to go back and we need to find our y value. And I can pick legitimately any single one of these equations to use. It does not matter if I use this one or this one. I could even use this one. But it needs to be one of the ones before we combine together. I can't come down into here, into this added stuff. We got to use one of these ones from before it was combined together. So I'll pick the bottom one just because arbitrarily I picked the top one before. So I'm going to use this guy to find my y for absolutely no particular reason. So I'm going to have my minus 4, but now I know my x is negative 1 minus 9y equals negative 23. Well, negative 4 times negative 1 gives me a positive 4. Minus 9y equals negative 23. Gorgeous. Minus 4 on both sides. I have my minus 9y equals negative 27. So what does our y equal? So our solution is the point negative 1, 3. Questions on this one? Okay. Let's do another one. Because sometimes we are not handed the same number on our variables. Sometimes we get stuff that looks like this. 2x plus 5y equals 1, and 3x minus 4y is negative 10. And just like on the last one, how we manipulated it, we multiplied one of them by negative 1 in order to make it have that same number opposite sign. We're going to do the same thing here. Just because I'm not multiplying by negative 1 doesn't change the fact that I can multiply whatever the heck I want, as long as I multiply both sides of my equation. So what we're going to do is we're going to pick a variable that we want to eliminate out, and we're going to find a common multiple between those coefficients, between the numbers in front. Yeah, let's get rid of x, because honestly, because it's got smaller coefficients, we're going to wind up with less obnoxious numbers. It doesn't matter, but let's get rid of the x this time. So I need to find a common multiple between 2 and 3. What is a common multiple that 2 and 3 go into? 6. So we're going to aim for our x's to have a coefficient of 6. So this top equation, what am I going to need to multiply it by? If I want that to be a 6 in front. 3. On the bottom equation, what do I need to multiply it by? 2. Remember, I want one of them to have an opposite sign.
Negative.
So let's do this one as a negative. This one already has minus signs in it, so maybe we'll lose some of those. So I'm going to multiply the top one by 3 and the bottom one by negative 2. I want them to have the same number with opposite signs. So I'm going to bring them this way. 3 times my 2x gives me 6x. 3 times 5y gives me 15y. And 3 times 1 gives me 3. On the bottom one, 3x times negative 2 gives me minus 6x. Totally how I draw an x. Minus 4y times minus 2 gives me plus 8y. And minus 10 times minus 2 gives me positive 20. So now I have my one variable that has the same number and the opposite sign. So we're ready to add these together in our old school column style. So we have 3 plus 20, giving us 23. My equal sign still right here. I've got my 8y plus 15y, and we get our 23y. And my 6x plus negative 6x, 0 x's. If you do not feel like you need to write down the 0x, you do not have to, but I feel like it does help us keep track of stuff sometimes, so I like to write it down. But we don't need that on the next step for sure, so I know I have 23y equals 23. So what does y equal? 1. Now we need to go back and find our x. I can pick any one of these 4 equations to use. I could use my 2x plus 5y equals 1, my 3x minus 4y equals negative 10. I could use the 6x plus 15y equals 3. I could use the negative 6x plus 8y equals 20. Any of them are fine. They all do the same thing. I'm going to go ahead and grab this one, the 2x plus 5y equals 1, just because it's positive values mostly and smaller numbers. We like those. So we're going to have our 2x plus 5 times our y, which is 1, equals 1. And then we're going to simplify that. We've got 2x plus 5 times 1, which is just 5. Then what do we do? I heard it. We're going to subtract 5. So we've got my 2x equals 1 minus 5 gives me negative 4. So what does my x equal? Negative 2. So my solution is the point negative 2, 1. If we had chosen to eliminate out the y's first, we would have gotten the exact same answer. It genuinely does not matter which one you do first. It does not matter. Driver's choice, creative freedom. Okay, one more that we're going to do, and kind of like yesterday, we're going to end with a little story. But there's some like this on the homework, and these show up a lot. And honestly, these have a tendency to show up on things like PSAT. They love these kind of fundraiser stories. So we've got here that Becca and Jasmine are selling candy bars for a fundraiser at school. Becca sold 3 caramel bars and 5 peanut butter bars for $13. Jasmine A sold 8 caramel bars and 2 peanut butter bars for $12. And we want to know how much each bar costs. We're trying to figure it out just from their receipts. We don't have the individual costs, but we know how many they sold and we know how much they made. So what are the things we don't know? What are our variables going to be? How much for each bar, right? So we have 2 different kinds of bars. We've got our caramel bars and we've got our peanut butter. Also, this is the only type of fundraiser I ever participate in. If you get the box of candy bars I can buy that day, I will buy one. If it's the order ahead, no thank you.
A lot of fundraisers are just order ahead nowadays, I think.
I know. I refuse to do that with esports. I refuse. It's going to be t-shirts or the candy bars you carry around in the box. Only options. I refuse to do the order aheads. So what variables do we want to use? You can use whatever we want. We could use C and P. We could use X and Y. We can use happy face and heart. Like, it genuinely does not matter. What do you want to use as variables? I'm just going to use C and P then. When we have situations like this, look for clusters of information. Equations are written in groups of 3s. So what we have here, we have that Becca sold 3 caramel bars, 5 peanut butter bars, and a total of $13. That's 3 pieces of information. I've got 3 caramel bars, 5 peanut butter bars, and $13 total. We also have that Jasmine A sold 8 caramel bars, 2 peanut butter bars, and $12. Those are going to be our 2 equations, one for each person. So for Becca's equation, how could I write what Becca sold as an equation? Super close. She sold 3 whats? 3 caramel bars. So 3 caramel bars. We don't know how much each caramel bar is. Yeah. Maybe each caramel bar is $1.25. Maybe each caramel bar is $5 because it's like a 2-pounder caramel bar. I would 100% buy that. The caramel bars are the best ones. Just saying. Even as a Reese's addict, the caramel bars are the best ones. By far. And I will fight for that one. So we have 3 caramel bars, and what else are we going to put? Plus 5 peanut butter bars. So I'm going to use P for the peanut butter bars. Equals $13.
Wait, if you like the caramel, what is your favorite best out
Peanut butter patties.
I'm pretty sure another are.
They are. They're the tagalongs. The chocolate covered ones that are like.
Yeah, the tagalongs.
Yes. I grew up in Illinois, and so they were called peanut butter patties. Because there's 2 different bakeries for Girl Scout cookies, one for the West Coast, one for the East Coast, and the line is the Indiana-Illinois border. So the fact that I grew up in Illinois means those are very clearly peanut butter patties. And I am very clearly right, and Indiana's wrong. All right, what is Jasmine A's equation going to be? 8C plus 2P equals 12. Now we're facing the exact same issues we had in the last one. We've got our 2 equations, but none of them have that same variable, so we're going to need to do some multiplying in order to be able to solve this. I'm just shrinking these so I can have a little bit more space over here.
These are smaller than my
2 and 5 is
Yeah, we could aim for canceling out the p's because the 2 and 5, it's easier to spot because we can see those 2 will multiply to be 10. Absolutely valid. So what would we need to multiply this top equation by? 2. What are we going to multiply the bottom equation by?
-5.
-5. I want them to have the same number with the opposite sign. So that's going to give us, top one multiplying by 2 is going to be 6c plus 10p equals 26. And our bottom one, it's going to get real big here for a second. It's okay. Minus 40c, minus 10p equals minus 60. My coffee just splashed in my face. Love that so much. All right, so now we're ready to add these two together. Adding in our columns. Our 6c plus negative 40c. Negative 34c. The 26 plus negative 60 gives us negative 34. And our 10p plus negative 10p cancels out. So what is the cost of a caramel bar? 1. Divide both sides by negative 34. Now we got to find out how much a peanut butter bar costs. And I have 4 options for equations. I could use this one, or this one, or this one, or this one. I don't recommend this one. This would be the hardest possible way to go.
I think we should do 3c plus 5.
Let's do this one then.
Because it's the smallest.
The smallest coefficients. So I've got my 3 times my c of 1 plus 5p equals 13. So I've got my 3 plus 5p equals 13. What next? $5p equals 10. So how much does a peanut butter bar cost? $2. So the caramel bars are $1. The peanut butter bars are $2.
You got 2? Wait,
What'd you get? Where'd I lose you?
3,000 plus 5 equals 13.
Plus 5p.
Yeah, I did that. 3
Okay.
plus 5 equals 13, right?
Uh-huh.
3 on the both sides.
Minus 3 on both sides.
10.
Mm-hmm.
About 5.
Oh, that's why.
There we go. It happens. It happens.
So how do you know which one to go first?
It doesn't matter.
So like when we put in the solution,
Oh, so on things like this, it's not going to be an ordered pair because we picked our own letters. So it's not, it doesn't matter which one it is. So this type, we won't have to put it as an ordered pair. The caramel bar is $1, the peanut butter bar is $2. So if we're picking the variables, we do not have to put it as an ordered pair. It's when I give you the equations with the x and y, that's when we put them as an ordered pair. Valid question. Good question. Okay. Questions on this one? This is probably the hardest one of the day. And in fact, it was also the last one.
Yeah. Over.
So you guys, it's the same one as yesterday. Same one as yesterday. So now you guys can finish this out. Let me know if you guys have any questions. You guys have, yeah. You guys have 8 minutes until the announcements start. And Marley, you've got to pass here. It's not until like 8:30, so that's why I didn't like rush it to you.
Marley, where is mine? Oh, is it here?
Why is this pen like glitching? I'm really not happy with that. No. The whole pen just like fell apart. No, not that way. That way. Yeah.
me see. I'm talking so I can see.
I'm trying to solve it.
Oh, I know.